Hi everybody, this is David Thompson. This is a video to introduce the game called Stormworks for people who might be interested in using it for academic purposes, for a variety of different things. I've had this conversation recently at the COMPIT conference where I saw a lot of PhD papers where potentially this tool, this game, could be used for teaching applications, to create some sample data. To be honest, I don't really know, but I wanted to record my thoughts in a video so that you can come to your own conclusion. So first of all, it's a game. It's available in the Steam platform, which is what you see here. It costs about 20 euros. Let's see what it costs these days, 24 maybe. As long as you can get the Steam platform installed on your machine, then you can get this application, as you can see here, 21 euros more or less. So it's an application which the game itself is really about creating ships and helicopters and vehicles and doing kind of search and rescue missions. So that's what the game itself will try to guide you to do. I'm going to create a new game here and show you how to get started in what I'd call sandbox mode. So typically what I would use if I was going to use this for educational purposes or anything else. So basically I've created here a custom game which automatically puts it in sandbox mode. You can pick a place where you start. So these are kind of different locations around the map. You can add so-called add-ons, which is kind of a bit complicated. I won't go into too much detail, but these are, as you can see, very large vessels or things like power stations which you can add to the map. But that's more for advanced use cases. I'll come back to that. So I just want to show you how this game works and how it, can kind of hopefully give you a basis for how it could be used in research projects or to create demonstration data, which is my personal use case, or as an educational tool. So the basic concept is you spawn in as a character. There is a multiplayer mode, so you can have several characters in here. As you can see, there's some what we call static environment here, where you can walk around. So these are sort of parts of the base game, but the key thing that you want to do in Stormworks is to use these workbenches. So there's a workbench here inside the hangar. It looks like this, and there's another so this is to spawn creations which are for land-based. So helicopter has to take off from the ground, airplane, car, but the key thing, especially for the COMPIT community, is the ability to spawn in vessels. So first of all, you can see here that there's weather. If I press M, you can see there's a map. I've just realized what I'm going to do here is I'm going to unlock the map. You can, as you can see here, control the weather. So let's just get rid of the rain. You can control the wind, as you saw there. So you've complete control over the environment. What you'll see in the map is that this is the world. So it's relatively small. Some big islands down here. A lot of small islands, these little white dots you can see all over the place. And an Arctic area with icebergs. There is, as you can see here, temperature. So this is dynamic actually. So it's warmer in the south, it's colder in the north. There's precipitation. So here's a low pressure, I guess, where there's some rain approaching these islands. There's wave height as well. Sorry, that's fog. So there's fog in the north here. And then there's wind, which of course affects the wave height. So this is a dynamic weather model. But just to let you know, there is a weather model, and as you'll see, this weather does move around the maps here. So there was a low pressure here, and wind coming in behind it, I guess. So it's modeled in a semi-realistic way. You can move around the map, and you'll see that the map has various facilities. So there's a diesel gantry here where you can buy diesel. So there's a pier here. There's water depth, as you can see. So this is all navigable waterways here. And places to anchor, with sand. This is a railway system. There's hospitals, there's airports. So there's basically the infrastructure, to allow this game to work, with missions and all this kind of stuff. And that might come in handy if you want to model certain operational scenarios, of course, so a ferry scenario going between two harbors, an ocean-going vessel going between port to port, etc., etc. So I know these are topics that all came up in the Compet paper. Now, the key part of this application is a voxel-based building engine. So you can build, as you can see here, simple structures. You can basically build a vessel this way. I'm not an expert builder in this system, unfortunately. There are people who are very efficient at building. So you can see I can build with blocks. I can build with pipes. So I need to rotate the pipe. I have no idea how to rotate the pipe at the moment. But you can see here I can build simple piping systems. And I can add all sorts of sensors. So if you look in here, we've got these building blocks. We've got pipe, or basically fluid transportation blocks. You've got vehicle control, so you can see here for aircraft or for underwater, you've got fins, control surfaces, wheels, mechanics here. So this is hinges, all sorts of doors, sliders, grippers, pretty much any kind of mechanical device you can imagine can be created with this. Propulsion, so we've got engines, propellers, air propellers, water propellers, a variety of different engines, and then you can see here we've got equipment for on board the vessel, so life rafts, fire extinguishers, flares, ropes, to make it actually possible to operate the vessels. More safety equipment here. Then we've got logic, so you can see here an add, a blinker, capacitor, clamp, memory register, a less than function, a greater than function. So there's actually, you can create extremely advanced logic, and you can create your own custom logic chips as far as I remember. You have a variety of displays here. So they started off like steampunk, dials and gauges, but you can actually, it's gone into fully electronic displays here. So these are different monitor sizes. And as you'll see in a moment, you can do, full electronic displays. And then very importantly, we have sensors here. So altimeter, angular speed, cameras, gimbaled cameras even, microphones, water level detectors, laser point, so distance measurement, impact sensors, pretty much, anything you could imagine here, rain, sonar, temperature, tilt, extremely good set of sensors here. And then a bunch of blocks for building out your fluid and electrical systems and modular engines. And then as you can see here, microcontrollers. These are a bunch which I've downloaded from, there's a workshop. So there's a Steam workshop which allows you to download creations from other users, right? So I can't remember how to use this. So the key thing is you can build, and you can build with a huge amount of logic. I'm not going to build, and this is the beauty of a commercially available game, because other people have built extremely wonderful, beautiful creations in here. So I'm going to load in this one. So you've got a pretty good 3D viewer where you can see this thing. You can slice through it, so you can see inside to get an idea of the layout. You can see the bridge up here, but I don't think we, as an academic and let's say the research community, need to look into, the building too much. There are plenty of people who can build vessels for us, and there's plenty available on the workshop. As you can see here, I've favorited, 20 or 30 here, but there are literally hundreds of these things. So the most important thing is you can, in sandbox mode, I don't need to pay for the materials or anything. I can just spawn this vessel in. Now that this vessel is in the world, you can see that it's reacting to a set of game physics parameters such as the wind and the waves. So you can see it's gently rocking in the waves. So you have a simple hydrodynamic model. And let me see. Yeah. So I can actually press F1 and see what my CPU is doing there. I can press F2 and this will show me the bodies as far as I remember. Physics bodies. And these are used for the buoyancy calculation. So you can see there my whole computer is slowing down because it's displaying these as well as doing the calculation. There's a bunch of simplification that goes on to make the sort of simulation, the real-time simulation, as far as I know. But so far, there's basic hydrodynamic simulation. There's a wind. Well, I guess it's the same calculation, different foot number. The wind is simulated. You'll see that has effect on the vessel, how fast it goes, the resistance it has to the water. And you'll see that cranes and mechanisms also have physics. So I'm pressing the home button on my keyboard. It just allows me to fly my camera across to a certain place. Now the key thing is that everything in here, I can press the buttons here, and then all of the physics and the logic that I've designed in here. So you can see there, this button is actually turning on the hydraulic actuators or these rails to push that platform down, and it's turning on these lights at the same time. So a very simple bit of logic. When that is triggered to on, turn on the lights and move this thing up and down. That whole logic is throughout the ship. So the other thing is that because these mechanisms work here, so this is actually a working crane, this is a working winch, you can actually simulate the operation of a vessel. So you can, as you can see here, we've got sort of dynamic, I thought this was a rope, it's actually a hose pipe. So let's take that off. But essentially, yes, we can simulate the operations of these vessels. So we can attach a cable to that, attach it to a vessel and tow it. We can have multiple people on here, one person operating the crane, another person putting some cargo into position, and even tying the cargo off here with these rope anchors, as you can see here. This is what I'm going to do. So when I've got my hose pipe here, I'm going to attach it to my hose, and then I'm going to turn on my hydrant water pump. Okay, it doesn't work. I think I've got to turn the engines on. Normally, there's a system behind this fire hydrant which connects to a pump, which will pump water through this hose pipe. So I can actually do very advanced things like that, like using that hydrant, turning on a water pump, and putting out a fire, for example. So very advanced operational, considering this is a game which costs 20 euros, pretty advanced operational scenarios can be simulated with air quotation marks. In the bridge here, I'm going to do a few things. You're not going to have the sound of the game here, so I'm going to sit in the seat. Highly simplified operation of this vessel. So I'm just, as you can see, I'm turning a key here. It's starting the engine, but behind the scenes, there's actually a bunch of logic going on behind the scenes. So the fuel air mixture is simulated. The battery has to be charged, for this electronic display to work here. I'm going to start the engine, and you'll see here that all of these gauges, spring into life. So I start my engine. Engine goes immediately up to kind of working speed. It's kind of dropping down there. You'll see that the temperature creeps up. This is not degrees Celsius. I assume it's simply 1 to whatever value. You can, of course, add in your logic chips something that will translate this in-game temperature to something more like a realistic temperature on the display here. yeah, so what I want to show here is that the complete operation of this vessel, is possible in this game as a simulation. This is a Lua script here which is running, and it's actually an interactive touchscreen, so I can use my keys here and zoom in and out of this map. It's very pixelated because that's, it's a little script running here which is simulating a little computer program running on the screen inside a computer program. You can see here this is actually a working radar. It's not detecting the land here, but it can detect vessels and things in the water. We are going to speed up a little bit, take the clutch off. So that, in this particular case, is not a very realistic way of operating a vessel. You don't necessarily have a manual clutch like that. But what you'll see is that we're cruising off here quite a good lick. And that's because I've taken the clutch off. The propellers, as you can see here, are spinning, and as you can see here, I've got rudders which work. So the whole simulation in a very simple, low fidelity form of this vessel is possible. There's actually in here a full dynamic positioning system. So if I turn this on, this clutch into neutral, and it will, if I turn it off and on, it will then attempt to keep the ship on station. So again, if I jump out of my seat here, it's the best way to see. You can see the red dot there. You can see the speed at the top, and if we click on thrust, we'll be able to see what the thrusters are doing. So we're going backwards, we're going looks like to port here, and it should bring that red dot into the crosshairs there, which you can just about see, and it will bring it back into position. So fully working dynamic positioning system. You can see here cameras, fully working cameras looking off the back and the front. This is, I think, an infrared gimbaled camera. We won't use that just now. But yeah, I think you get the general idea. I'm just going to start steaming off again. These ships are, way faster than they would be in real life. That's because it's a game. People want to get to their, their goal in real life. But you can design a vessel which will operate at a speed which is much more realistic. It's really just about how the vessel's been designed. What I want to show you now is in this custom menu, I can increase the wind up here. And it's kind of a simulated wave motion, so the waves will build up over time now with this wind, and it'll get larger and larger in waves. So it instantly gives you some waves, and as you can see here, we've got some kind of simulation here of how the vessel behaves in the waves. What I found is that these vessels, they don't roll very much because actually there's a dynamic stability system that somebody's implemented. You can't see the fins, they're kind of hidden inside the vessel, which is obviously not like real life, but somebody's implemented here a system which basically uses fins to dynamically reduce the rolling, but there are vessels which roll in a more realistic way. So relatively good simulation of the hydrodynamics of this vessel, and you can make that more realistic, but of course it's not as realistic as using a full-on sort of simulation tool. But again, there's a lot of things going on here at the same time. This vessel is essentially operating with several subsystems here at the same time. So our engines there are warming up. There's a thermodynamic model for the engine here. They have to have cooling, they have to have fuel and air to work. And what I'm going to show you is, if I can remember how and you can see here the ship's rolling. It's harder for me to walk around it. It's the motions here are affecting my ability to move around, and if you've got very high motions you can fall off. The full vessel can flood, and the compartmentation and watertightness is modeled. So if I close this door, which is a watertight door, and this has water inside it, which actually can happen quite easily because we have here these working decks. You'll see that water can come in here. It's not modeled at a very high fidelity, but you'll see that the sort of splashes here are just kind of going over the edge. But if there were bigger waves, water would come in here. This designer has actually designed a full scupper system, so these are scuppers, and the water is pumped out automatically. What I wanted to show you is the real-time data that this ship is generating. So apologies if it's making you sick moving around. It actually makes me feel a bit motion sick, but this first-person perspective, especially if I move around quickly like this, isn't very comfortable for everybody, so I'm aware of that. So we can see here there's some data on this display. This is just a mirror display of what's going on in our engines. We can see here what's going on in our batteries. Everything is full. But the interesting thing is that these engines, if I can remember the key, sorry, just bear with me here. I've freaked it out. I need to navigate back to a safe place. Let me just find out which key it is. I've forgotten, unfortunately, but generally it's possible to... here we go. So I'm holding down a key, and this is showing me the real-time data for this this thing that I'm looking at. So you can see there the throttle. I don't know why the throttle is changing. It should be fixed. There could be some logic which is controlling that. Starter's off. The RPM is changing very slightly. It's at 9. So again, it's not a realistic revolutions per second. It's per second. That's why. There's a temperature there. Again, I don't think this is any kind of accurate temperature, but the point is these values here are coupled together. So if I put more cooling water through the pumps going into this engine, the temperature will go down. If I turn the cooling water off, the temperature will go up and the engine will explode. You can see there's a fuel flow and an air flow, and that's a ratio of, what's that, 10 to 1 approximately, which is kind of realistic. Real-time data, and one of the key things that I want to do with this system is to extract this data into a data historian, because as you can see here, even just for this engine alone, there's, what's that, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12 parameters here, which are dynamically generating data. And this goes for everything that I can get this kind of label for. So if I look at a light, let me just try, there you go. You can see the light, it says light true, electric one. So it's got electrical power and it's on. Every single thing in this game has these so-called IOs, the input output. So the door lock is false. And this means that you could generate a huge amount of data for a data historian, and of course data which is coupled. Are the doors open, are the doors closed? You can actually see that these lights go on here because there's a sensor. If I look around here, I'll find that there's a sensor somewhere that's telling this to turn the lights on. I can't see it just now, but trust me, there's a sensor somewhere on the wall that's determining whether the lights are on or not off. I'm feeling a bit seasick. Let's just use this fly mode to get outside again. So this vessel is generating thousands of data points potentially simultaneously in real time. And the most amazing thing is that this simulation can have maybe realistically 2 or 3 vessels of this size operating at the same time. So I can do some deep sea diving. So we've got submarines and all sorts of underwater vessels that actually have to have water tightness. We can have several vessels on the top. You can do anchor handling scenarios. but at the same time generating a whole bunch of real-time data. So that's the pitch. I'm hoping that some people from TU Delft, from TU Hamburg, Harburg, anybody here, is interested to work with me to use this engine, this source of simulation in the marine industry for something that's truly useful. Whether it's training, whether it's teaching students the concepts of ship design, which you can see here is a pretty obvious thing, or whether it's teaching people about operational scenarios. This is what I really want to do with this pretty amazing little game, which is, I think, 2 or 3 developers have made over the course of a year or so, and that thousands of people are using, and as you can see here, creating absolutely amazing kind of creations here. So that's all from me. I'm going to stop my video and look forward to your comments.